So hopefully you can see that. Yeah, this is Lasair, which means flash or flame. If you speak Irish or Scots Gaelic, and that's because the main input for Lasair is coming from Queen's University Belfast and the University of Edinburgh. These are the people on the slide, and if you want to look at our research note, there it is on the front page. What is it? So this is basically a kind of summary of our list of high-level requirements: an alert annotator and filter, searchable repository, a Lightcurve repository, a means to access postage stamps, provider of context information and spectroscopic info, etc. Cross-match against archives and live services, live alert streams, as well as multi-messenger services. What kind of an object is it? Can you maintain watch lists, etc.? And then there's a few other things, some of which are implemented, some of which are not, in terms of follow-up. We also have a feed out to the Zooniverse, which I'll tell you about in a minute. So we've been operating since the end of May 2018. We've managed to process 127 million alerts so far. About 9.2 million of those are aggregated into objects with 2 or more detections. So our background comes from static sky detections, although we are ingesting, of course, solar system events. This is just a quick overview of the architecture, a very simplified version of the architecture. The thing to stress here is we are producing, or we are ingesting, the full stream of data from the Rubin Observatory, currently, of course, ZTF. We are in the process of effectively scaling up everything. The system runs on a cloud infrastructure within the UK grid community called IRIS. So it's in the UK Science and Technology Funding Council funded infrastructure. And basically we are ingesting into a combination of databases, of file stores, and of so-called NoSQL type databases, etc. And we feed out to our customers in potentially several different ways, including Kafka. So here is our prototype broker. So the live broker is up and running. We've got a prototype coming up, the release of which will be very soon, so that you can start to exploit some of the things that we've been adding. So for example, I said it was a searchable alert and query platform. So of course, most brokers offer a simple cone searching facility. And of course, they offer a filtration facility. So we're filtering using an SQL-like language. It's mostly SQL, but it's kind of behind an API. And we've added some APIs which we want you to test. These are, again, coming very soon. It's a Lightcurve repository. So of course, we have a repository of all the Lightcurves of all the aggregated objects in our database. And we have an API to query that, along with grabbing the image information for each of the alerts. It gives you information about the probable possible host information. So Dave Young has written the software called Sherlock, and that's something that we're currently in the process of scaling up. And that gives information about whether or not this transient may or may not be associated with a known galaxy or star. And of course, it does open up to very large galaxy catalogs, as well as the probable background galaxy that the alert might be associated with. So there's an algorithm behind this, which will be configuration managed. The plot, the little Grafana plot, just shows you the ingestion of ZTF alerts, and in yellow, I think, is the Sherlock classification of all those alerts, i.e. the context classification. Do you want a watch list of objects? Yes, we can offer you that facility. We do offer you that facility. You can have up to 1 million items in your watch list, and you can monitor your sky by sky area if you so desire. Yes, I'll go on. Sorry, there's also, you can see actually the SQL query now allows you to match that against the watch list. You can join your query to the watch list and filter your matches against your watch list as they're coming out. Of course, it's a multi-messenger cross-matching service, so we tag alerts that are spatially and temporally coincident with the the 90% area of the sky of where an alert may be. We've been obviously trying to use different types of pipelines like Lightcurve classification, and in this particular case, we've been using Daniel Muthukrishna's Astro Rapid with some success into the pipeline in order to augment the information with a potential type of object. If users are finding themselves limited by the SQL-like interface that we provide, we also provide access via a Jupyter notebook, and you can spawn up whatever size of notebook you need to make your analysis and join your results with whatever other survey, for example, you want to do in this particular case. We have a collaboration with the Zooniverse, which is in beta at the moment, called the Superluminous Supernova Project. And we have volunteers, citizen scientists, looking at the rise time of light curves. And if they're longer than 20 days, for example, then they tag these as potential superluminous supernova. So that's currently in beta in Zooniverse, and they're getting their output from us via Kafka. So just a quick note about, I'm currently exploring the alternatives to relational databases as our databases get larger and larger, and have had some success with Cassandra, which is working for us reasonably well. The issue for us is, will the technology be around in 10 years' time? And can we query it the way that we want to query it? Anyone who knows about NoSQL databases understands that how you query the system very much
2 minutes.
Is the way that you have to design your database tables, or your column families, as they call them. And then as we get into the end, we adjust our data to various, well, in particular to ePesto, which we have a strong relationship with. And we're currently moving to a Kafka API output for that. So ePesto has just restarted in the last few days. So we're already adjusting data for those guys to follow up. And we have a relationship with SOX and Foremost, which we are required to produce output for. So what's next? We want you to test our APIs and look at our documentation we've put together to explain how they work. We are very interested in the new ZTF alerts that have force photometry in them, because that's relevant for us in terms of what we do with the LSST force photometry. We're joining our ZTF alerts to our ZTF data release 3. So again, we will be doing this in LSST land as well. We want to test the LSST alerts samples, both solar system and indeed the static sky. We've got some tech evaluations we're completing. We're finishing off some DevOps in the way that we deploy the broker, and we're continuing our Zooniverse collaboration. And that is it. Any questions?
Thank you, Ken. Gigi, we have time for one question, so pick it.
Okay, the first one came from Paula. Ken, are you planning to develop your own machine learning classifiers?
Possibly, but the likelihood is that we will also want to look at other people's machine learning classifiers as well. and talk about how we integrate those into our pipeline.
Thank you, Ken. Thank you, Guille, for dealing with the questions. And I want to thank all 5 speakers for keeping in time. It was